Good morning, everyone. I'm Shotade Olusegun. In today's video, I want us to dissect the emergence of finite universe by real eye relativity. So the real eye relativity there simply means real imaginary relativity. So we're going to actually, dissect how imaginary numbers and real numbers are so essential in this particular today's video. So we're going to say dissect the kind of phenomena we have beyond the real the real universe, because formula of everything actually extends beyond the real universe. So let's quickly dive into it. Now, this this is time energy wave model. So this is what I've been using to explain the visual representation of the entirety of the universe. So now time travels inversely to energy, and so by applying formula of everything, which is this particular formula, we realize that the time trajectory from the arbitrary suspension at classical level goes beyond the arbitrary suspension at quantum level. So that time trajectory gets connected to the real mass worth of electron, and we realize that that mass worth is injected back into the system. This is a stable fixed point, while this will serve as unstable fixed point. So by having this big mass worth of electron in this tiny suspension, we're going to have unstable kind of situation that will make the mass worth of electron to quickly decay, and that will propel momentum towards the singularity of the future, which is the black hole. This place can really serve as event horizon, while this is our black hole. This is the evolutionary expansion. So now that is the time energy wave model. So basically we have values, and so there is no uncertainty principle in this diagram. So if you want to know more about this time energy wave model, make sure you get some of my uploaded videos. Okay, so now I just want to go quickly into it. Now the situation we have here, where we have the real mass worth of electron outside time energy wave model, is something that has traveled beyond. So in my previous videos, I usually interpret it as being in higher dimension. So that is what I can just say. Now there is another thing that we have in maths, which is called complex number. So you have real number, then you have imaginary number. So if you look at what we have here, a plus bi, which is complex number, it's somehow not really related to the formula of everything, but if you look at the structural formula of everything, we have capital Um plus 4m. So we have plus relationship. So that plus relationship could serve as a suspension. Now, when you look at this, if we're to relate formula of everything to the complex number, so with complex number, we have a kind of situation where imaginary numbers influence real numbers. We have that. So this is the imaginary axis, and this is the real axis. So we have 45 degree of light cone. We have the trajectory of light to be in 45 degree. So any extension to this part or any reduction to this part will actually be influenced by increase in imaginary number relative to real number. You understand? So we have that kind of situation, but it is so complex. People don't, though we know that imaginary world can actually influence real world, but how do we get to that kind of how do we get to that level? So what I want to do in this video is to relate the results we have in applying formula of everything to a complex number and see how that can actually lead to finite universe. Well, first of all, we're going to look at infinity. Where in one of my previous videos, I describe infinity to be like the effect of distance. I define infinity to be effect of distance. Now, when you look at it at classical level, we have the real mass worth of classical right here. Now we have arbitrary suspension, which is arbitrary mass worth. Now, this, if we have at the boundary of collision of nuclear fusion, if we could have repulsive force, you understand that is so intense that tritium and deuterium we have to conquer before they could form another element, which is helium. Then it simply means that the kind of infinity that we have here is the type that will not go beyond the arbitrary suspension. And so that is why we have the feeling of the fact that nothing can travel faster or beyond the speed of light. So that is at the classical level. Now at quantum level, what do we have there? At quantum level, we see that the kind of infinity we have is different, because we have spontaneous symmetry breaking at the arbitrary suspension here, and we then travel to get the real mass worth of electron. We travel beyond the limit. So now the kind of infinity we have here is synonymous to a situation where you have object traveling towards the event horizon. At the point of event horizon, the object will remain static to observer. So, but the real fact is that there is spontaneous symmetry breaking. So at that spontaneous symmetry breaking point, there is a brief disconnection, and so the observer is only stopped with that disconnection, and will not be able to see further. But the real fact is that the object has even traveled into the black hole, which is the further reality that the observer will not be able to see. So those are the two situations of infinity, and now we're going to see how we can break that down to reality of what we're trying to explain here. So first of all, before I go deep into that infinity, I want us to look at the imaginary values that we have here. The imaginary value is square root of -1. That is the real world. But the thing is, there is a kind of limit constraint. For imaginary, you have from 1 to 4, and so the 4m that we have here is not by mistake. So this 4 has something to do with I4 of the imaginary number, and you can see that here I have approximately I3. I have this as a relativity sign to I4. What do I mean by that? If you look at the value of I3 here, that is -I, which is imaginary. So for the fact that we have arbitrary mass worth here, and we have the real mass worth of the classical right here, that simply means that the infinity is going to be in form of imaginary, so it's not going to be real. But the kind of infinity we have here at the point of spontaneous symmetry breaking to connect to the real mass worth of electron, that could be likened to I4, because the value of I4 is 1, and the 1 is a real number. You understand? So why I3's value is not a real number. So the arbitrary suspension we have here is somehow related to the kind of effect we have at quantum phase, where you say that you know that when you are acquiring potential worth or energy, you travel against gravitational field and then you accumulate potential energy. But when you are in the gravitational phase, you travel not against gravitational field. So you are going to have weight, lightness of weight. You understand? So it could be that because we have arbitrary mass worth here, so the mass worth we have to decay before it can actually affect us. That could be synonymous to the kind of protection we have for the earth by magnetic field. So that protection is what uh, shields the earth against solar wind. You understand? So before anything can actually affect us on this earth, then the magnetic field will have been decomposed. You understand? So basically that is the kind of what we have here. So in the gravitational phase, we're going to experience lightness of weight, but when that gravitational field or effect is more intense, then that could, later affect the real world, the real world of what is traveling inside the black hole. So now let's so let me quickly explain more. So we have I to be square root minus 1, then I square is minus 1, and then we have I cube, which is I cube or I3, which is minus I, and then we have I power 4 to be 1. So I power 2, I power 3, then I power 4 to be 1. So you can see that we have iteration of inverse. So this I could be an inverse of this I power 3, and then this I power 2 can be an inverse of I power 4. You understand? So that is what we have there. And for us to get the worth, the value of this 4m, another thing we need to know is that if you want to solve the power that is beyond 4, the limit that we have for imaginary number is from the I to I raised power 4. So if you want to solve any I that is far beyond 4, then you will have to divide the power by 4, and then you now use the remainder as the power of the I, and you can see what we have here. I raised power 31 equal to I raised power 3, then equal to minus I. So that is the solution. That is how you can see that the I force serves as the constraint of imaginary figure, because when you go beyond the power of 4, then the value becomes rough, something that you cannot really interpret. So that is that, and you can see that by having this 4m, which is the weak conveying force of formula of everything, that could serve as the quantum limit, the quantum constraint, and we have seen the effect here. But basically, by having I4 to be 1, that means that the quantum limit will actually lead to real mass worth. You understand? So basically, imaginary number or arbitrary suspension could lead to reality, and that is why we have the I, which is imaginary number affecting real number. So that is how I can explain that. So now let's get to this fact. Now, for us to get to the emergence of finite universe by real relativity, we need to know what constancy is, what variance is, what instancy is, and then what infinity is. So variance could as well be variation. You understand? So now when we look at the time energy wave model as we have it here, we have equilateral triangle, and by having it to be in 45 degree, that represents the constancy of gravitational field, and this the 45-degree trajectory, which could be likened to light cone, serves as constancy of electromagnetic field right here. So constancy, so we can see that in time energy wave model we have constancy of light, and so the constancy of light will prolong the mechanical system that we have here. And like I have said, the mechanical system is to have radiation at quantum level that will facilitate the mass, accumulating mechanism at classical level. So that is the system. And so we have electromagnetic field right here. So electromagnetic field sheds mass worth, and so as a result of that we have the real mass worth of electron outside the system. And this is the wave amplitude. By the time we put that in the formula of everything, we're going to get a very tiny fraction at the low energy state. So this low energy state, we can liken it to the ground level of quantum stages or quantum level, so I mean the ground state of electron. And for us to have electron beyond the ground state, that could be likened to the neutron star, a situation where we have electron in the nucleus, you understand, and we know that kind of situation will be unstable, and that will further decay the neutron star to make it collapse into the black hole, you understand. So basically what we have the constancy like this, and constancy will actually elongate that mechanical system of expansion. Then the curvature of time wave to energy wave, we can liken that to the variance of time's wave or variance of energy's wave. So now you know that the mass worth that we're going to have will be progressing towards this wide space. So the mass worth we have here will be smaller to what we're going to have here. So there is going to be a lot of variation, and we know already that what the electromagnetic field operation is different from gravitational field operation. Gravitational field operation is to accumulate mass, is to converge mass. So why electromagnetic field is to diverge mass, you understand, to diverge mass worth. So now we have variance and constancy. Now let's look at instancy. Instancy comes, one of the natures of time is instancy. Time travels instantly, and if we're to actually dissect what clock measures, it's the frequency of radiation right from the high electron state to low electron state, you understand. So we can say we have encapsulation of time reading, we have electromagnetic difference of high state to low state, we have the encapsulation of that in time scaling. So whatever your time the clock reads is electromagnetic speed of relativity scaling, which is the effect of time on energy. So now time is instant, but if we look at this trajectory, we can see that the trajectory is prolonged. If we're to say something is instant, it's going to be immeasurable disruption of time relativistic scaling to energy, you understand. But in this case it is not short. So what I'm trying to say is that we shouldn't have a lengthy trajectory, but now we have lengthy trajectory because time we have to travel from this arbitrary suspension through this low arbitrary suspension to connect to electron's mass. So by having that lengthy trajectory, it means that the instancy of time can be converted to something that we can measure. So we have measurable instancy right here. but the nature of time is instant. Because if you look at this could be likened to what is it called, entanglement, and we know that quantum entanglement transmits information instantly. You understand? So now we now have, what next we have? Yes, we have infinity. What can we interpret to be infinity? Just like I said the other time, we can say the arbitrary suspensions that we have here is likened to measured infinity. So because the expansion is being configured in such a way that we could measure it, so we can actually liken that to a kind of situation whereby if you are on, let's say you have an office, you can travel from your home to office. You know that one is finite. But what if you now travel half distance and you divide that by half, and you continuously do that? You will see that it will then travel infinitely. But the reality is that you can travel from your office to home. You understand? But if you now divide, if you walk half distance, you keep on dividing that by 2, then it becomes infinity. So you can see the effect of infinity. Another effect of infinity that we may need to dissect is, for instance, if you're on Earth, you can look, if you look outward, you see that it's more or less like the Earth has no boundary. But if you travel away from the Earth, you'll be able to see the full shape of the Earth, and then you get the reality that the Earth is finite. So basically that is what I'm trying to prove right here. Infinity we may have. So now let's look at this diagram here. Here, the emergence of finite universe by its 4 properties. The 4 properties are infinity, instancy, variance, constancy. So now, infinity by definition should be immeasurable elongation of time, relativistic scaling to energy. Then, instancy should be immeasurable disruption of time, relativistic scaling to energy. But now, when you have instancy being in relativity to infinity, what do you have? Then you now have measurable instancy, which is what we have up there, and then you have measurable infinity. So when you now have measurable infinity to measurable instancy, what will that lead to? Before we see what that will lead to, let's dissect the other 2 properties, variance and constancy. So variance should be unstable reaction of energy to time relativistic scaling, unstable. But constancy, that deals with stable reaction of time relativistic scaling to energy. But when you now have these 2 relative to another, if constancy is in relativity to variance, you will have stable mass worth, and then you will have unstable mass worth. So when the 2, so by having this and by having this, we can actually have finite universe. So by having measurable infinity, measurable instancy, stable mass worth, unstable mass worth, we can have finite universe. So when you now relate these 2 to these 2, we have finite universe. So that is that. Then another thing I want you to briefly look at is this time energy wave field interaction. In time energy wave model, we have gravitational field relative to electromagnetic field. And so we could say that in the sun, like when the sun will only collapse when the radiating force of the sun has dropped to gravitational field. That is when sun will collapse. So now, basically, we usually have the radiation force to be at constant, speed with gravitational field, and that is why sun is being sustained. And so in this, where we have strong nuclear force, we only have electromagnetic field, and here where we have weak nuclear force, we only have gravitational field. So this can actually explain the reason we may have finite universe. So when we interpret infinity the way it ought to be interpreted, then we are likely to have finite universe. So we should, no matter how no matter how vast universe will surely have a boundary, because once you have a beginning, which is the Big Bang as we have it, then there must be an end to that, which is the black hole, and so there must be boundary for our universe. So I believe this